Hello friends, welcome to my YouTube channel. In this video lecture, we are going to solve further questions in this chapter from this chapter CRP5 of Keith Williams General Navigation book. So far, I have solved 90 questions and uploaded them already. Do watch those video lectures if you haven't yet, and then come back to this video lecture in which we will solve the next questions. So let's begin from question number 91. I'll directly take it from this book. Ground speed is 510, distance is given. What is the time to go from A to B? Now the time taken will be equal to distance divided by speed. So distance is 43 nautical miles, speed is 510 knots. Okay, and so what is the time from A to B? So 43 divided by 510 is equal to 5 minutes. So what is the time in minutes? It is 5 minutes. So correct option will be option alpha. Question 92. Speed 122, distance 985. What is time? So time here will be distance by speed. So 985 divided by 122. 8 hours 4 minutes. Option bravo. Next, speed and distance given again time. So time will be distance divided by speed 236. So 354 divided by 236 is 1.5 hours, so 1 hour 30 minutes. Next, speed distance given what is time. So time is distance divided by speed of 435. So 1920 divided by 435 is 4 hours 24 minutes. So the closest option here is delta 4 hours 25 minutes. Speed and distance given what is time. Time is distance divided by speed. So 3560 divided by 345. 10 hours 19 minutes. So option delta. Okay. Next. Question 96. Speed and distance given what is time. Again distance divide by speed 480. 5360 divided by 480 is 11 hours 10 minutes. So correct option is alpha 11 hours 10 minutes. Next. What is time to travel distance 980 nautical miles in 95 at 95 knots? So 980 divided by 95 is 10 hours 18 minutes. Section 480 divided by 95 is 5 hours 3 minutes. So the correct option here is option Charlie. Question 98. Speed distance given what is the time taken? So time will be distance divided by speed. So 103 divided by 105 58 minutes. Closest is option A 59. Speed distance given what is the time? So distance 84, speed 120. So 84 divided by 120 is 42 minutes. So the correct option here is delta. Next, speed given, distance given, what is time? Again, time will be distance divided by speed 135 knots. So 433 divided by 135, 3 hours 12 minutes. So correct option will be option bravo. Next, question number 101. Runway direction given, surface winds are given, calculate headwind component. Now headwind component formula is wind speed into cos theta. What is wind speed here? It is 35 knots. Cos theta. Theta is the difference between wind direction of 35 degrees minus runway direction of 83 degrees. So 35 minus 83 amounts to minus 48. So cos minus 48. The cos of minus 48 is 0.669 something. That multiplied by 35 is 23.4. Okay, 23.4 knots. So the correct option here is 22, 24, 20, 26. So 23.4, so less than 23.5. So the closest here is option Charlie 22. For takeoff, aircraft requires a headwind component of 10 knots, crosswind limitation of 35 knots. The angle between runway and the wind is 60 degree. In short, theta is 60 degree. What is the maximum and minimum allowable wind speeds? The headwind component formula is wind speed into cos theta. What is minimum headwind component required? 10 knots. So 10 knots equals to wind speed into cos of 60. So wind speed will be 10 divided by cos 60 is half. So 10 divided by 0.5 is 20 knots. So in order to get a 10, in order to have a headwind component of 10 knots, it is necessary that wind blows at a speed of 20 knots. Now crosswind component is wind speed into sine theta. Crosswind component maximum is 35. Wind speed into sine 60. So wind speed equals to 35 divided by sine 60 is 40 knots. Right? So the closest option here is 20 and 40. Accurate. Option A. Next, runway direction given to you. Winds given. What is crosswind? Now theta. Wind direction minus runway direction 50 degrees. Crosswind component formula is wind speed into sine theta. So 40 knots into sine 50. So sine 50 into 40, 30.6, approximately 31 knots. So option alpha. Next, magnetic track heading variation task given to you. What is true wind velocity? We want wind in terms of true direction. So convert this magnetic track and magnetic heading into true heading now, or true track and true heading respectively. So magnetic track is 075. Variation is 11 east, right? So if variation is east, magnetic will be east, meaning magnetic direction will be less than true direction. Now here magnetic track is 075. Variation given is 11 east. Now variation is magnetic least. That means true direction will be more than magnetic. So 075 plus 11, 086. Okay, that is your true track. Similarly, true heading will be 066 plus 11, 077. So track 086, heading 77, as 275. Aircraft, yeah, that's fine. So that's ground speed. Now aircraft lies 48 nautical miles in 10 minutes. This gives you a ground speed of 88 knots. So substitute 288 or insert 288 in this option. It's 8677. So wind 335 at 46 knots. 335 at 46 knots. So closest option here is option Charlie. 340 at 45 knots. Okay. Next, magnetic track, magnetic heading, variation, task given to you. Calculate true wind velocity. Again, true. Now convert magnetic track into true track in using variation 15 east. Whenever there is east variation, magnetic will be less than true, or true will be more than magnetic. So your magnetic track is 210. So true track will be magnetic track plus variation of 15, that is 225. So track is 225. Next heading will be, similarly heading will be, true heading will be magnetic heading plus 15 variation, that is 230. So 230. Next task is 360. Ground speed 64 into 60 divided by 12, 320. So ground speed is 320. Winds 264 at 50 knots. Winds 264 at 50 knots. So option A is the closest option. Option A is the closest option. Okay. Next. 4040 task given, wind speed given. What will be the maximum drift angle obtained from a wind? Now, let's say this is your north datum. This is your, this will be your course 04. This will reciprocal will be 220. Now to get a maximum drift angle means to have a crosswind, a direct crosswind which is perpendicular to your track or to your runway, right? A direct crosswind of 90 degrees will produce a maximum drift angle, maximum drift. Anything less than 90 degree will produce a drift, but nonetheless it will be less than the direct crosswind of 90 degrees to your course or to your track. Now with respect to course 040, with respect to course 040, the maximum drift angle will come from a wind which is blowing at 90 degrees to this course. So any wind which is inclined at 90-degree angle to course 040 will produce a maximum drift. So 040 plus 90 is 130. So either the wind should blow from an angle of 130 degree, or 40 minus 90 is minus 50 plus 360 is 310, or the wind should blow from 310 degree. Either directions, either crosswind will produce a maximum drift angle. Okay, so the options here are 120, 130, 210, 330. So correct option is 130. Now let's say your course is 220. So in that case, a crosswind which is perpendicular to the course 220. So 220 plus 90, 310 in that case. So, or 220 minus 90, 130. Okay. So again similar. Even for 040220 it will be same. Crosswind 310 or 130. If the options, if four options mentioned, the given four options, there isn't any option which contains either 310 or 130, select that option which is closest to this, any of these two numbers. 108. Flight level is given. Outside air temperature is ice is standard. Cast, track, heading, variation given. What is wind velocity in terms of true? So first we will find wind velocity in terms of magnetic and then finally convert it into true. So let's put the values. Track is 222, heading is 215, okay. Ground speed will be 105 divided by 21. Convert this into hours. So 105 into 60 divided by 21, 300 knots. So now you are left with task. Now find task. How will you find true airspeed? So what you'll do is, outside air temperature is ISA standard temperature. So ISA temperature at flight level 120 is 15 minus 2 into 12 is 15 minus 24, that is minus 9 degrees Celsius. So let's first find true airspeed from CX3. So outside air temperature minus 9, indicated airspeed or calibrated airspeed is 200, so altitude is 12,000. This gives you a true airspeed of 238.6 knots. Okay, 238.6 knots. So now we will write this value in here. So, so what is wind velocity? Wind velocity is 067 at 69 knots. 067 at 69 knots. Be aware this is magnetic. Now convert this into true. What is variation? It is 15 west. So when variation is west, magnetic is west. Magnetic will be more than true. So true will be less than magnetic. So 067 minus variation. So 052 at 69 knots. This is in respect to true datum, true north. So correct answer here will be option delta. 052 at 69. So closest is delta. Next, question number 109. Course, tasks, wind speed given. What is the maximum drift angle? Maximum drift angle will be obtained for a wind direction of what? So your course is 095. So let's say this is your north datum. Okay. Your course is 095. Maximum drift angle will be given by a crosswind or will be produced by a crosswind which is directly perpendicular to your course. Which is directly perpendicular to your course. Now your track is 095. So 095 plus 90 is 185. So a wind coming from a direction of 185 degree, or 95 minus 90, which is 005, a wind coming from a direction of 005 degree. Either of these winds will produce maximum drift angle. So here the option is 185. Select that. What is the time to go if speed and distance is given? So time is equal to distance divided by speed. 500 divided by 240. 500 divided by 240 is 2 hours 5 minutes. So 2 hours 5 minutes is nothing but 120 minutes plus 5 minutes, 125 minutes. So option Charlie is the correct option. Next, question 111. Distance x to y is 40 nautical miles. Time x to y is how much? 12 hours 32 minutes minus actual time of arrival. 12 hours 52 minutes. So 12 hours 52 minutes minus 12 hours 32 minutes is 20 minutes. Is 20 minutes. So ground speed will be equal to distance divided by time. 40 divided by 20 minutes. So convert that into hours. That is equal to 120 knots. Next, now we have to find the time of arrival at Zulu. We know distance between Y and Zulu, Yankee and Zulu is 75 nautical miles. Ground speed is 120 knots. So time taken to cover 75 nautical miles will be 75 by 120 37 minutes. Now, you are leaving Y at 12 hours 52 minutes. So 12 hours 52 minutes is your departure time plus 0 hours 37 minutes, that will be equal to 13 hours 29 minutes. So the closest is option Charlie. Next, similar question. Distance AB is 30 miles. Time AB is actual time of arrival at Bravo 10:27 minus time you left Alpha, that is, so this is 17 minutes. Speed AB, speed ground speed will be distance divided by time, so 30 into 60 divided by 17, that is 105.8, so 106 knots. Now distance BC is 20, speed is 106, so time taken to travel 20 miles will be 20 divided by 106, 11 minutes. 11 minutes. Now your departure time at Bravo is 10 hours 30 minutes. Total flight time is 11 minutes. Your arrival time at Charlie will be 10:30 plus 11, that is 10:41. So option Bravo, closest. Question 113. Similar question. Distance xy is 30. Time x to y is 1450 minus 1420, 30 minutes. So speed will be how much? Distance divided by time. So 30 divided by zero point 0.5 is 60. 60 knots. Now with this speed of 60 knots and distance 20 miles, you will require a time of 20 minutes. So 1450 plus 20 minutes is equal to 15 hours 10 minutes. Option Bravo. What is true altitude if outside air temperature is plus 35 degrees Celsius? Pressure altitude is 5000 feet. So we'll do it here. Since an altimetry sum. Now pressure altitude is 5000 feet. Outside air temperature is plus 35. Okay. Now true altitude is pressure altitude plus altitude correction if temperature is warmer than ISA, pressure altitude minus altitude correction if temperatures are colder than ISA, right? I have explained this whole concept of altimetry errors in a different playlist. Do watch that videos. You will get a better clarity. Also, I have solved all the Oxford altimetry questions. So practice them also. Along with that, altimetry questions from RK Bali have also been solved. So do watch those videos as well. Coming back to this, ISA temperature at 35,000 feet will be 15 degrees Celsius minus 2 into 5, 15 minus 10 is 5 degree Celsius. So ISA states that at 5000 feet you must have 5 degrees Celsius, but reality is different from ISA. Outside air temperature or actual temperature is 35. So ISA deviation is equal to outside air temperature minus ISA temperature. So 35 minus 5 is 30. So ISA deviation is 30 degrees Celsius. Now to correct for altimetry errors engendered by temperature. okay, engendered by non-ISA temperatures, the correction formula is 4 degrees Celsius multiplied by ISA deviation into per thousand feet. 4 multiplied by ISA deviation 30,000 feet. 5,000 feet, so multiply by 5. So this is equal to 600 feet. So true altitude will be, it is plus 600. So you are going to add this correction to your pressure altitude. So 5,000 plus 600, which is 5,600 feet. As you can see, ISA deviation is plus 30. So plus 30 means warmer. So you are going to add it. So final answer is 5,600, option delta, the closest. Again, what is true altitude if outside air temperature is plus 30 and pressure altitude is 7,000. So pressure altitude is 7,000. Outside air temperature is plus 30 degree Celsius. Now ISA temperature at 7,000 feet is 15 minus 2 into 7, 15 minus 14, that is 1 degree Celsius. ISA deviation will be outside air temperature minus ISA. So 30 minus 1, which is 29. That means actual atmosphere is warmer than ISA by 29 degrees Celsius. So the correction formula is 4 degrees Celsius multiplied by ISA deviation into altitude. So 4 multiplied by 29 into 7, 7,000, so 7. So 4 into 29 into 4 into 29 into 7 is 812. So your true altitude will be 7,000 pressure altitude plus correction 812, that is 7,812 feet. 7,008. Approximate, the closest is option alpha, 7750. Next, indicated airspeed, flight level, outside air temperature. Next, we'll do question 118, which is find time. Now, time is equal to distance divided by speed, which is 500 divided by 440. 1 hour 8 minutes or 68 minutes. Next, distance will be equal to speed into time. So speed is 400 knots, time is 42 minutes. So 400 into 0 hour 42 minutes is 280 nautical miles, option Charlie. Next, here distance will be 420 speed into 47 minutes. So 420 into 0 hour 47 minutes, 329 nautical miles. We'll stop here. With this, we have covered or answered all the questions from CRP5 chapter from Keith Williams General Navigation book. Very simple, easy to score. So I suggest you all that you keep practicing these questions based on CXB, CPL, ATPL airline exam. Make sure you get these questions correct and score maximum marks when it comes to these questions. If you have any doubts or questions, let me know in the comment box of this video lecture. I thank you for your time. Subscribe to this channel if you haven't yet. Share this video with your friends. Hit the like button if you have liked this lecture. If you haven't liked, dislike button. So thank you. I'll see you in my next video lecture in which I will solve new questions from time chapter Keith Williams. So don't miss that video. See you there.